Did you know that some stars can explode at regular intervals without actually dying? We're about to witness an exciting cosmic explosion that will be visible from Earth. Unlike a supernova, where stars completely burn out in a spectacular display, an older star can also produce what's called a nova. This event is similarly spectacular, and the best part is, it's not a one-time event. It repeats. The upcoming nova in the Corona Borealis system is about to detonate, and it promises to be a breathtaking sight. Many people dream of seeing a nova with the naked eye from Earth. Novas are enormous nuclear explosions that temporarily make stars thousands of times brighter. When this nova occurs, it will likely be one of the brightest objects in the night sky for a significant period. For space enthusiasts, this is extraordinary news, as such events don't happen every day. The star in question, T Coroni Borealis, detonates approximately once every 80 years, with the last explosion occurring in 1946. Now, it's ready to repeat this celestial event. A nova happens when two stars in a binary system interact in a peculiar way, releasing a vast amount of energy. This leads to a sudden explosion and a sharp increase in brightness, making the star appear as if it's newly born in the sky. The term nova comes from the Latin word for new. The famous 16th-century Danish astronomer Tycho Brahe coined the term after witnessing a brilliant new star in the sky. However, what he observed was not a new star being born but rather a violent eruption with an ensuing nuclear explosion in an existing star system. A nova typically involves a white dwarf star in a binary system, where the white dwarf accumulates material from a companion star. When enough material is collected, the pressure and temperature become so intense that a massive explosion occurs, which is what we observe as a nova. Unlike a supernova, where a star is destroyed, the white dwarf survives the explosion and can potentially produce more novas over time. The primary difference between a nova and a supernova is that a nova occurs in a binary system, where a white dwarf star pulls matter from a companion star. In contrast, a supernova marks the end of a star's life, either due to the white dwarf reaching a critical mass or the collapse of a massive star. A supernova is much more powerful and destroys the star entirely. The brightness of a nova is impressive, but it's far dimmer than that of a supernova. In the case of T Coroni Borealis, the nova will shine brightly but won't reach the destructive magnitude of a supernova. This upcoming nova will light up the night sky, providing us with a spectacular cosmic show. Although novas are typically visible only through telescopes, the proximity of T Coroni Borealis means that this event will be observable with the naked eye, despite the star being 3,000 light-years away. The system is located in the Corona Borealis constellation, also known as the Northern Crown. It's easy to spot due to its semicircular shape, which makes it stand out in the northern sky between the more well-known constellations of Boötes and Hercules. The brightest star in the arc is Gemma, also known as Olla. Once the nova happens, it will appear as a brilliant new star in the constellation. The best time to observe this nova will be late in the evening when Corona Borealis is high in the sky. This event is rare, and the next eruption of T Coroni Borealis will likely occur in about 80 years. The first known nova eruption in T Coroni Borealis was recorded in 1866. When a sudden bright star appeared in the night sky, observed by many people. Since then, the star has exploded periodically, and the upcoming nova promises to be another stunning display that will illuminate the night sky for all to see. Space experts began revisiting this peculiar phenomenon in 1946, exactly 80 years after its initial observation. The 1946 emissions were studied in greater detail by astronomers worldwide. Historical records, including those by Abbot Burchard von Herberge in 1270, show that this nova has been a notable object for humanity for centuries. Herberge observed a remarkable increase in brightness in the region of the Crown Borealis. More recently, astronomers have detected heightened activity in the Toni Borealis system, with significant fluctuations in brightness and an intense surge in radio and X-ray emissions since 2015. These observations closely resemble those from previous outbursts in 1866 and 1946. In 2018 and 2023, further unexpected brightness variations were recorded, prompting specialists to examine their data more closely. Comparing it with the records from 1946, They discovered striking similarities. These recurring patterns suggest that the next nova event may occur in September 2024, potentially making the nova one of the brightest objects visible in the night sky for several weeks. This white dwarf star could continue producing novas after this explosion, though it may take many years before it fully dissipates or triggers a Type Ia supernova. Researchers, through simulations, have determined that the frequency and magnitude of novas depend on various factors, including the amount of accumulated matter and the efficiency of the accretion process. The interactions between the two stars in an episodic nova system, like Toni Borealis, also play a critical role. In systems like Toni Borealis, the white dwarf continuously siphons material from its companion star, a red giant. As this material accumulates on the white dwarf's surface, it forms a hydrogen layer. When this layer reaches a critical mass, nuclear fusion begins, resulting in an explosion similar to a massive hydrogen bomb. The sudden release of energy causes a dramatic increase in brightness, making the nova visible. While astronomers are currently focused on Toni Borealis, other nova systems are also expected to produce similar outbursts. One such system is RS Ophiuchi, which consists of a white dwarf and a red giant. Its last explosion occurred in 2006. And with a periodicity of around 20 years, the next nova may occur as soon as 2026. Another system, US Scorpii, has nova events roughly every 15 years. However, since this system is located 47,600 light-years from Earth, observers will need a good telescope to witness its next explosion. Unlike supernovae, where stars are completely destroyed in a catastrophic explosion, novas involve a white dwarf accumulating material from its companion star, often a red giant. When enough material is gathered, a nuclear reaction occurs, temporarily boosting the star's brightness by thousands of times. These periodic nova events offer a spectacular view of the dynamics within binary star systems, providing insight into stellar evolution and the mechanisms of energy release in extreme environments. The upcoming nova in the Toni Borealis system, located over 3,000 light-years away in the constellation Corona Borealis, is expected to be one of the brightest objects in the night sky for several weeks. This event follows the historical pattern of periodic nova outbursts, with notable occurrences in 1866 and 1946. The consistency of these eruptions gives astronomers a unique opportunity to study the development of binary star systems and the physics of nuclear reactions that occur during these events. From a scientific perspective, novas help us understand the life cycles of stars and the dynamics of energy release under extreme conditions. While they are less destructive than supernovae, they still represent significant events in stellar evolution, where the fate of a white dwarf depends on its ability to accumulate and process material from its companion star. The visibility of novas, especially those closer to Earth, makes them prime targets for both amateur and professional astronomers. Events like the one in Toni Borealis will continue to capture the imagination of stargazers, as they offer a brief but spectacular glimpse into the energetic processes shaping the universe. As we approach the next expected nova in September 2024, astronomers are preparing to study and analyze the complexities of the event. This ongoing research promises to reveal new insights into the dynamics of binary star interactions and the role of novas in the broader context of cosmic evolution. The dynamic and ever-changing nature of the universe is exemplified by nova events like the one in Toni Borealis, which continue to fascinate and inspire curiosity about the cosmos.